In this video, we will take a look at the trace table. So, what is a trace table? A trace table is a tool that can be used to manually step through each line of an algorithm or a program from start to finish to check the contents of each variable, as well as show any outputs after each line has been carried out to check if the algorithm or a program is producing the correct results. Here, we step through each line of an algorithm or a program, and at each point, the value of each variable and any output is recorded. A trace table is thus used to dry run an algorithm or a program to help us identify any logic errors. A trace table can also be used to understand the purpose of an algorithm or a program by checking the intermediate steps and output data. Since computer algorithms could also be expressed using flowcharts and pseudocode, trace tables can be used with these as well. Let's now see how a trace table looks like. The typical columns of the trace table could include column to show line of code, columns for variables and outputs, and a column for any comments. Each row of the trace table shows one line of code that is executed and the value of each variable and any output at that point. Where certain lines are repeated in the code, this could be reflected in the trace table by adding rows for each line, that is, repeated and recording the value of each variable and any output at that point. Let's take an example. Suppose a bank has launched a new credit card and they are offering 5% cashback on purchases over £500 in the first month as an introductory offer, with the maximum cashback capped at £100. So, if the cashback amount is more than £100, then it is reduced back to £100. The pseudocode for the algorithm is on the screen. Let's assume that the purchase amount is £2,500 and work through this pseudocode and complete the trace table. Here, we have omitted the columns for line of code and comments to fit things on one screen. The first column represents the variable, called purchase amount. The second column represents the variable called cashback, and the last column represents any output. In the first line of the pseudocode, we input the purchase amount and store it in the variable called purchase amount. Therefore, we record 2,500 under the first column in the first row of the trace table. In the second line, we set the value of the variable called cashback to 0. Therefore, we record 0 under the second column in the second row of the trace table. We haven't made any changes to the value of the variable purchase amount here. Therefore, we record 2,500 similar to first row under the first column in the second row of the trace table. In the third line, we are using the if statement to check the condition if the purchase amount is greater than 500. Here, we are checking the condition but are not changing the values of the purchase amount or the cashback. Hence, we record these as 2,500 and 0 respectively under columns 1 and 2 in the third row of the trace table. Since the purchase amount is greater than 500, we enter the if statement and move to the line 4. Here, we calculate the cashback amount as 5% of the purchase amount by multiplying the purchase amount by 5 over 100 and store the answer, which is 125, in the variable cashback. Hence, we record the cashback under column 2 at 125 in the fourth row. And since there is no change to the value of the purchase amount, we record it as 2,500 under column 1. In the fifth line, we use the if statement again to check if the cashback calculated is greater than 100. Here again, we are checking the condition, but are not changing the values of the purchase amount or the cashback. Hence, these remain as 2,500 and 125 respectively under columns 1 and 2 in the fifth row of the trace table. Since the cashback is greater than 100, we enter the if statement and move to the line 6. Here we set the cashback to 100, as that would be the maximum that we would pay for any purchase amount greater than 500. Hence, we record the cashback as 100 under column 2 in the 6th row. Again, there is no change to the value of the purchase amount, so it stays the same as the previous row, and we record 2,500 under column 1. In the 7th line, we end our nested if statement. We are not changing the values of the purchase amount or the cashback here either, so we record these as 2,500 and 100 respectively under columns 1 and 2 in row 7 of the trace table. In the 8th line, we are ending the outer if statement. Again, we are not changing the values of the purchase amount or the cashback, so these remain the same in row 8 as the previous row, i.e. 2,500 and 100 respectively. In the 9th and final row, we are printing the cashback as an output, but are not changing the values of the purchase amount or the cashback. Hence, in the row 9, we record the purchase amount under column 1 as 2,500, the cashback under column 2 as 100, and the output under column 3 as 100. I hope you got the idea over how trace tables can be used to step through each line of code to inspect the value of each variable and any output at that point. Let's recap. A trace table can be used to step through each line of an algorithm or a program from start to finish and record the value of each variable and any output at that point. Each row of the trace table shows one line of code that is executed, including any lines that are repeated and the value of each variable and any output at that point. This helps in checking if an algorithm or a program is producing correct results, i.e., doing what it is expected to do, and to identify any logic errors. Thank you for watching. Please like, subscribe, and don't forget to press the bell icon to get a notification when we post a new video.